Thank you for joining us today for Modernize Your Data Warehouse with Azure Synapse and Confluent. Before we start, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place everyone feels welcome. Please ask your questions using the live YouTube chat. In the chat, I'll also be sharing some links to the Reactor Meetup page and monthly newsletters if you're interested in checking out what other sessions we have coming up. Today's session will be added to our Reactor YouTube page in 24 to 48 hours. And finally, I will share a link to our Reactor survey towards the end. If you have a few minutes, we greatly appreciate your feedback. I am now going to pass it over to Peri, TJ, and Joseph.
Awesome. Thank you so much for the intro. My name is TJ Lair, and I'm excited to be here today to present about how we can help you modernize and migrate your data warehouse to Azure Synapse with Confluent. So I'm joined with two fellow panelists. We have Peri Rocha, who's a senior program manager, and Joseph Morais, who's a cloud solution architect. Gentlemen, thank you so much for being here today. Excited to present alongside you all.
Likewise. Hi, everyone. Absolutely thrilled you're here with us today.
Perfect. So let's jump into the agenda real quick. So first and foremost, we're going to do a little context setting. I think that's always beneficial. It's always a good thing to start with of what we're talking about today, how Confluent fits into the puzzle of data warehouse modernization, since Confluent itself is not a data warehouse. And then we'll move over to Peri discussing Azure Synapse in detail. So you just brought your data into Azure Synapse. What do you do next? How can you unlock value in that data that you migrated over to your cloud-based data warehouse in your Azure Synapse instance? And then Joseph is going to do a little demo. So it'll be demo time where we'll actually show this in practice of how we're connecting on-prem environments to Azure Synapse to make this migration as easy as possible and set up that real-time stream processing system. We'll finish up with some Q&A. So if you have any questions, feel free to drop them into the comment section. And then finally, we do have some swag available. So I don't know about you, but it's been a long time since I've been at an in-person event. And there's two things I missed. First thing is meeting people in person. The second thing, swag. So we solved that problem for you all. If you want to take a click on that QR code or click the link that we're going to drop in the comment section, you can get a nice warm sweatshirt, a beanie. I don't know about you, but it's also getting really cold where I'm at right now. So this will be a nice way to warm up. So feel free to fill out that form and get some free swag on us. So let's jump into it. So why are we talking about data warehouses? First and foremost, data is growing at a crazy rate. I don't think I can present a data warehouse presentation without talking about this number, right? 175 zettabytes of data by 2025. This is obvious, right? I get notified every time I take a picture of my daughter on my camera or on my phone saying, hey, you're out of data, right? The amount of data that we're consuming and we're producing is growing at such a crazy rate. And from a business data perspective, a lot of roads lead to a data warehouse like Azure Synapse if you want to turn that data into actual value. And it's a good place to land that data because from a cost perspective versus your traditional on-prem data warehouse, people see around a 50% TCO savings, right? The ability to decouple compute from storage and manage those things independently to hopefully get the value that you're after, but also manage costs is definitely a massive benefit when you migrate to a cloud-based data warehouse. And obviously, you're unlocking significant value with the downstream analytics that you can operationalize as you turn that real-time data or that big data into big value. So this unlocks a whole bunch of different business value use cases across a whole variety of industries. So once you have that data in your data warehouse, there's nothing that you can't do. But obviously, migrating to a cloud-based data warehouse is not an easy task. And sometimes this is a multi-year lift and shift in order to unlock the value that you see on the screen in front of you. So how can we make this easier for you? And how can we make sure that you, as you undergo this migration, it's not a multi-year lift and shift, you can achieve this business outcome as soon as possible. So when we see our customers doing migrations from on-prem systems to cloud-based systems like Azure Synapse, there's a few different challenges that they run into. One is high costs. So this hits on a couple of different veins. One, there's a cost associated with just doing a large lift and shift and a large dump into your cloud data warehouse. Your on-prem data warehouse has been around for multiple years. Not every data set in there is the most critical. So how do you only move the most valuable information to your cloud-based data warehouse? How can you do some of that pre-processing beforehand, so you're not just moving it all into your data warehouse and then seeing what happens next? And then obviously there's costs associated with copying this data as well. So if you don't want to land it in your cloud data warehouse, but you want to stage it in your data lake, or you want to stage it in a separate database, there's going to be copying data. There's going to be additional management of systems. So we see costs start to balloon out when folks try to create these kind of intermediary steps or these stepping stones as they move over to their cloud-based data warehouse. The second challenge that we see is just analytics-ready data is slow to get your hands on. That's because foundationally, a lot of these systems are built using the batch-based paradigm. I'm going to move this data to my cloud data warehouse every hour or every day or every week, whatever it is entailed for that particular use case. So everything is batch-based systems, batch-based APIs, and that slows down the time it takes for that cloud-based data warehouse user to get their hands on that data, especially if that data might still reside on-prem as you're doing your migration piecemeal. And then finally, as you have these two separate environments stood up and you're actually executing on your migration, being able to keep these two environments in sync from a consistency perspective, from a management perspective, from a security perspective is really difficult, right? So the problems that I mentioned just compound as you have your holistic data warehouse architecture living across multiple environments. So how's Confluent fit into this picture? How does Confluent help kind of accelerate your migration? So first and foremost, Confluent's mission at its core is to set data in motion. So what is data in motion? It's a new term, but it's in comparison to that data at rest paradigm that we're all really familiar with. So data in motion takes the computer science of underlying traditional databases and really turns it on its head. Instead of passively storing data and only accessing it periodically, the principles of data in motion allows for ubiquitous access to data from any system, right? SaaS-based applications, databases, on-prem, cloud-based, it doesn't matter. And as that data is generated, it provides real-time connections and continuous processing needs so that you can react and respond to data and events as it happens in the moment. So what does this actually look like from a technology capability perspective? So we've built out a cloud native complete data in motion platform that can live anywhere. So starting with cloud native, right? We have fully managed capabilities that allow for elastic scale. So as you connect data and as you process that data in real time, you can scale up and down with your needs. And this is fully integrated with Azure from a networking, a security, and a management perspective, and it's all available via Azure Marketplace. It's complete in the sense that we've built on top of the open source foundation of Apache Kafka. So Apache Kafka is the open source project that our founders built back at LinkedIn, and it's quickly turning into the standard for connecting real-time systems and real-time data flows. But there's a lot of missing pieces to Kafka that we've extended and we've solved for. So being able to secure it, being able to manage it, being able to do this all easily with pre-built connectors and stream processing capabilities. And then finally, we know that your data resides everywhere, right? Data is distributed across on-prem systems, multi-clouds, and being able to have this system live anywhere is definitely extremely critical. And so while a lot of our customers first and foremost get started with Confluent in the cloud, we do offer a self-managed software that you can deploy on-prem so that you can do real-time processing directly where the data resides on-prem, and then you can attach and link that cluster to your Azure cluster so that you can simplify the migration process. So let's see what this looks like when you take our platform and you plug it into the data warehouse puzzle. So now, you've reduced the total cost of ownership because you can do a lot of that real-time processing directly in stream instead of landing in additional systems for pre-processing. And then with our fully managed capabilities, we really changed the TCO of data pipelines. And I'll go into a little more detail around what that TCO change looks like. The next thing is we can help you power net new analytics and applications, right? We can do this by connecting your analytics professionals to more data that resides anywhere and bringing it into your Azure Synapse to power those analytics, right? And then we can also make those analytics and applications real-time. So real-time is a necessity for a wide variety of use cases, being able to react to events when they happen. So having that real-time event streaming and event processing capability right alongside your data warehouse as you're connecting all those different systems is really beneficial as you think through that next generation of analytics and applications that you want to build out. And then finally, you can get more data to and from your data warehouse. So we have 120 pre-built connectors that make it really easy to connect to any system so that you can move data effortlessly to and from your cloud data warehouse. So let's go through these in a little more detail so you understand the full context around what we mean with each of these points. So starting with the manage your TCO of your modern data warehouse. So when you talk about TCO of your data warehouse, you can't help but think about the pipelines that are associated with that TCO. So what we've done is we've really changed the game in terms of the TCO of standard message queues, right? Which is kind of a spot that our technology is sometimes pinned to, message queues or ETL systems. So when you compare us to those traditional MQs, we actually see a 29% savings when you compare us to those legacy systems versus our cloud native systems. So when you look at the total cost of ownership of your data warehouse and the pipelines associated with it, you should see a cost savings with our fully managed capabilities, with our pre-built connectors that make everything a lot easier to manage as well. You can also move a lot of that heavy processing on those joins that happen, every day on those massive tables into streams. So instead of them taking minutes in your cloud-based data warehouse, they can happen in milliseconds. This allows you to optimize your cloud data warehouse spend, or maybe your database or your data lake spend that is the landing zone for your data prior to it landing in your cloud-based data warehouse. And we've seen customers like Sykes Holidays Cottage, which is based in EMEA, make this shift, make this change, and see a significant cost savings in their overall data warehouse strategy. 10x ROI over the last 3 years through these subtle changes. Next, I want to talk about how we connect to hybrid and multi-cloud systems and applications. So first and foremost, building net new applications on Confluent and building those net new data streams on Confluent is extremely easy. You can do this in the language of your choice. So if you do want to create that join prior to it landing in Azure Synapse, you can do that with SQL, you can do that with Java. Or if you want to do something a little more advanced of a join or building materialized views or doing some aggregation or whatever it may be, you can do that all within Confluent, within the language of your choice, so that you can pre-process that data prior to it landing in Azure Synapse, prior to it landing in an additional data application. You can connect to all of your old data no matter where it lives with our pre-built connector ecosystem. And some of these connectors, like our Oracle database connector, has CDC capabilities. So if your traditional on-prem data warehouse is built directly on Oracle, we can have that connector out of the box ready to go for you, and have that change data capture capability directly built into our connector as well. And then finally, we can link any environments, so on-prem or multi-cloud environments with our cluster linking capabilities. And Joseph is going to go into a little more detail on this and actually demo this in person. So when you have Confluent living on-prem and you have Confluent living in Azure, you can quickly connect those clusters and mirror your data so that you can get access to that on-prem data that's flowing through Confluent directly in Azure. So the third and final point is around that real-time event processing capability, right? So when you start to change your mentality away from just, I have batch-based systems, I'm going to continue to run my reports on a batch-based time frame, to I want to do things in real time. I want to build net new applications and analytics that can interact with the world as it changes. It's really important that you build on top of a foundational real-time platform that can give you the throughput and latency that you require. And Confluent has best-in-class numbers when it comes to latency and throughput. So high throughput, low latency processing, and that's due to the underlying technology of Apache Kafka. So the distributed nature of Apache Kafka allows us to scale to massive amounts of numbers, massive amounts of events at a message per second rate, so that you can make sure that all the applications that are using data that feeds through Confluent are using the most up-to-date information. This is, it's not really a fair comparison, but just want to make sure that you understand the difference, right? Like cloud data warehouses are really, really good at what they do. They can run analytics at scale. They have extremely powerful analytics so that you can turn all that data into value. But it's just not a comparison when you compare to the real-time processing capabilities of Confluent. So if you're doing any sort of real-time processing, or you want to do some joins that happen in seconds and milliseconds instead of minutes in your cloud-based data warehouse, that's where Confluent really, really shines. So I'm going to pass it over to Joseph to kind of go into the tech details and break it down to the bits. So Joseph, over to you.
Fantastic. So what you see here is a high-level overview of a scenario bridging on-prem into Azure. So as you can see, with many of your established enterprises, you have if you've been around longer than a few years, maybe not if you acquired someone, you probably have a lot of things sitting in a data center, right? And that could be our Confluent platform, which can run anywhere, or even open source Apache Kafka. We can use our, as long as you're Confluent on one of the ends, you can still cluster link into Apache Kafka and pull data into Azure, right? And then you can see all the different things we're doing downstream. And then you could also connect into other data centers if you wanted to, right? So let's say, hey, I'm already in Azure, but I want to be global. I want to be in every single region that Azure's in. We can help do that through cluster linking. So this is a high-level view. We're going to kind of double-click into all this. So let's move forward. All right. So just to kind of quickly run through, we're going to go through each one of these in detail. The first thing we're going to do is we're going to migrate, right? So we're going to connect up our cluster. We're going to deploy a cluster on-premise. We're going to connect it to an Oracle database that's sitting there. We are going to then connect that to a cluster in the cloud. We're going to optimize. So once we have all of our data in the cloud, and you'll see why, because there's another data source, we're going to use KSQLDB to do all the transforms and the combinations and the merging of data. And then finally, we're going to modernize. So we're going to use our connectors to send that downstream into a more modern data warehouse. I don't want to, I think you guys will all figure out what it is, but let's continue on. So we're going to take a closer look at cluster linking. So Confluent cluster linking helps us put our data in motion and allows us to connect all of our clusters on-prem, in cloud, or otherwise to form a global data mesh. Data is syndicated and replicated between on-prem and on-prem, cloud and cloud, on-prem and cloud, and any mix that fits your outcomes. All of this is achieved by leveraging the internal replication mechanism of Kafka and preserving offsets between source and mirror topics. Cluster linking has two distinct advantages over existing replication technologies, Mirror Maker 2 and Confluent Replicator. The first is cluster linking works natively preserves offsets in mirror topics. Though this is possible with the other two technologies, it requires additional tooling to make work. Because cluster linking provides byte-by-byte replication, offsets are preserved, which is an important facet for disaster recovery scenarios. Second, cluster linking utilizes native Kafka replication, while the other two solutions are built on top of the Kafka Connect framework. Ultimately, with cluster linking, you simultaneously improve your replication mechanism and simplify your stack. So now let's talk about optimizing your data warehouse with stream processing. KSQLDB is an event streaming database for working with streams and with tables of data. It is used to perform streaming analytics and is being used for general stream processing and data integration use cases. It is a distributed, fault-tolerant system that separates compute from storage and has these modern cloud-native characteristics, such as being able to scale elastically during live operations without losing data or producing incorrect processing results. It supports aggregations, joins, windowing, event time-based processing, and automatically handles out of order and late data. We'll get to see plenty of KSQLDB during our demo today. So you can build all these awesome streaming applications with KSQLDB. This year, we released some tools that will make managing streaming applications at scale even easier. The first is our Stream Catalog, which is a knowledge base for data in motion. It's like the company's public library for event streams. The idea is to centralize all Confluent-related metadata from all of your clusters. With all the real-time processing we're going to do, it's important to determine, where did my data come from? Where is it going? And when or where, how was it transformed? That is what Stream Lineage does, providing a GUI to give us the answers to those exact questions. Finally, stream quality via our schema registry ensures that events have proper fields and field types, providing a mechanism for schema evolution without interruption, and in the near future will provide validation based on business rules. So now let's talk about modernizing the warehouse with net new data and applications. So TJ touched on this a bit, as well as he did with cluster linking, but there is this native API to Kafka called Connect, which allows us to source events from other systems like a relational database or mainframes into Kafka topics, right? So go out, grab the data, make it a Kafka event, or take events from a Kafka topic and then sync them into other systems. We're going to be showing examples of both of those in our demo. There are dozens of open source connectors out there in the wild. Now, Confluent has expanded on those open source Kafka connectors to further increase the number of available data sources and syncs in order to move data in and out of Kafka. A developer working with open source Apache Kafka will have two options: develop their own connectors using the Kafka Connect framework, or leverage the aforementioned open source connectors already built by the community. The challenge with the first option is the time and effort this takes. In 2019, Confluent increased its connector portfolio from around 10 to over 100 supported connectors. Through this experience, we measured that it takes an average of 6 weeks with a full-time engineer to develop one connector. And this is the time it took the world's Kafka experts. The challenge with the second option is, while all these open source connectors will be unsupported, this would generate significant risk for an organization deploying Kafka and event streaming into production. What would happen if something breaks? Would the organization feel confident about fixing these issues without help from the experts? This is why Confluent offers a portfolio of over 130 connectors, around 100 of which are developed and supported by Confluent, and another 30 or so are developed and supported by our partners with full validation from us. You can run these connectors anywhere yourself, on-prem or in the cloud. And during our demo today, we'll be featuring our Oracle Change Data Capture connector, which will allow you to efficiently add your data stored in any Oracle database to our real-time data pipeline. Now, between our connector ecosystem, we also have some proxies. We have an MQTT proxy for anyone out there in the IoT world. We have REST proxies for everyone else, and our robust client library, which you see above. Virtually any system can work with Confluent. Speaking of virtually any system, let me hand over to Peri, who will be guiding you through some exciting features of Azure Synapse.
All right. Thank you so much, Joseph. All right, so why don't we talk about what is Azure Synapse to start with, and what's the problem that we're trying to solve with Synapse? So when we talk to our customers, we've been in the business analytics and data science market for a long, long time. And when we talk to our customers about their challenges, the main concern that they're describing to us is that there's really two worlds that they need to manage. One is the world of data science, where you deal with big data, landing at high velocity, high throughput. You do a lot of experimentation on this data. you work with notebooks, and data comes in any format, any shape or form. It can be semi-structured, structured data, free text data, doesn't matter. So this is where analysts and data scientists will do a lot of experimentation on data, and they need to have the versatility of using different tools on different data scenarios. And the other scenario is on business analytics. This is the well-resolved problem of data warehousing, where it's really easy to store data and to serve data at scale. You get mostly relational data. It's a proven security and privacy method where it's really easy to categorize data according to their privacy levels and to secure who gets access to which data. It's very predictable performance as well. So if you need this much scale, this is how much hardware or this how much cloud scale you buy. So the data warehouse problem is really well resolved. And in data science, it really goes around the data lake. So you drop some files on a data lake and you explore data on those files as they sit there, right? Now, how do you bring those two worlds together, right? So how do you bring the world of big data and data warehousing together so that you leverage the same security models, you leverage the same performance benefits, and you have analysts and data engineers and business users on the same place while working with the data projects, right? So this is where Azure meets the challenge with a single service that provides both the ease of use and fast exploration and flexibility of big data environments, as well as data warehouses. And this is Azure Synapse. So we call Azure Synapse the limitless data warehouse. This is an all-in-one service where you can bring over your data to Azure Synapse. You can work on big data environments using Spark, or you can serve data using our scalable SQL engine in a single place where you can author notebooks and SQL scripts and work with your data. So it's a very broad product. If I look at the individual components of Azure Synapse, this is how we organize, and this is how you should think about Azure Synapse. So data comes from any sources, including Confluent bringing data over to our analytical runtimes. But data could come from any source, really doesn't matter. And the data can land on Azure Data Lake Storage. So let's say you just throw data in here as CSV files, Parquet, what have you, whichever format you prefer. You can have your choice of an analytical runtime to analyze the data. It could be a SQL engine that scales horizontally on a cluster. It's a massively parallel processing engine that scales horizontally at massive scale. Or you can use Apache Spark for machine learning and data preparation, for instance, which works on memory, of course. And so you can have your choice of an analytical runtime. And we also have the Data Explorer runtime, which is not on this slide yet, but I'll mention in a few minutes. On top of that, we have an integration platform that helps you bring data together. We have a management experience, I should say management and monitoring, and we have all of the security benefits that we get from a SQL engine. And you manage this experience in a tool that we like to call Azure Synapse Studio. This is our one tool where you handle all of the work that you do in Azure Synapse. Now, Azure Synapse works as a platform, so it allows you to use external services such as Azure Data Share. So if you need to share, let's say, some slices of your data to some branches or customers, you can use Azure Data Share for that. We have a very close integration with Azure Machine Learning. So if you're training models in Azure ML, you can export your models and import them into our SQL runtime, or you can just invoke Azure ML models programmatically using our REST API. And we have a very tight integration as well with Power BI, allowing you to author Power BI report within the Azure Synapse Studio experience. So this is Azure Synapse. It's an end-to-end analytics service that offers unmatched time to insight because it brings all of your data together in one place, and the tools for you to analyze. Doesn't matter the workload, the shape of the data, and etc. There's 5 main pillars to Azure Synapse. One is limitless scale. So once you bring data over to Azure Synapse SQL, you get a cluster that expands horizontally and can give you as much scale as you need. So let's say you have a small application and you don't have a lot of money to spend. You can have a cluster that's comprised of 1 or 2 nodes, or you can scale up to 60 nodes to serve queries to your users. It offers the benefit of powerful insights because of the integrations that we have with Power BI. it is this one unified experience where in one place you get to import, bring data, analyze, and serve data to your users. We have an instant clarity component to Azure Synapse, which is an HTAP engine that we call Azure Synapse Link. My slides are in a hurry. I apologize for that. So instant clarity offers you the opportunity to instantly replicate data from certain data sources into Azure Synapse without any ETL required. And we have an unmatched security offering in the industry where we have features like row-level security, column-level security that come included in the product without you having to pay for it. And when we talk about customers, besides all of those pillars, performance is very, very important. So they say, okay, but how do you scale? How well do you scale with Azure Synapse? Well, in fact, we've done a study, not ourselves, an external company ran a study where they find out that Azure Synapse, when compared to our competitors, were up to 14 times faster and costs up to 94% less than other cloud providers. This is really an unmatched price performance in the industry for this workload. So we have all of the goodies around security and integration and etc. But we're leading on performance as well. So we could spend the whole day talking about Azure Synapse. I'm not going to do that today. I have just a few minutes. So instead, I'm going to tell you about some recent announcements that we've made at Microsoft Ignite just a couple weeks ago. And then I'll tell you about how some of our customers are using Synapse. So we're super excited about Microsoft Ignite. You can see the detailed announcements on our blog. I see that the team already put here. So the team will put here the link for the Synapse blog where you can read all of those announcements in details. But long story short, we've announced the preview for Azure Synapse Analytics Data Explorer. So if you have log and telemetry analytics scenarios, super relevant for this discussion today. So let's say you're using Confluent to bring data over to our engine. You can use our integration with Data Explorer. And this is an optimized engine for free text and semi-structured files and data that are commonly found in web analytics and logs and etc. And let's say you have an IoT solution that you're bringing data over to Synapse using Confluent, for instance. The Data Explorer analytics runtime is optimized for data in this shape. So we're super excited about the integration with Azure Synapse Data Explorer within Azure Synapse. We've announced Azure Synapse Link for Dataverse. So on the previous slide, when I said that we offer instant clarity, we have Azure Synapse Link, which replicates data from some applications into Azure Synapse without the requirement for you to maintain any ETL jobs. We do that for some Microsoft first-party products today, and we announced the general availability for Azure Synapse Link for Dataverse. So if you're using Power Apps, Power Automate, Dynamics 365, the Power family of tools within Microsoft, they store data on something we call Dataverse, and it's really easy for you to replicate data from those applications into Azure Synapse today. We also announced database templates. For some industries, we are offering some standardized database templates where you can get started quickly, and you don't have to worry too much about designing database entities and etc. Those are well-established database layouts or table layouts that you see in the industry that accelerates your time to project and really standardizes how you work with data in several industries. So we're really excited about database templates on Azure Synapse as well. Also, if you're using Spark in Synapse, we've announced the preview of GPU-accelerated Spark pools. So if you're training machine learning models, or if you're doing data transformations that could use a little bit more compute, we're now offering GPU-accelerated Spark pools. So this means you get a lot more performance when you're using Spark pools within Azure Synapse, which is a big customer ask for us. Finally, we announced the general availability of Delta Lake support. If you don't know Delta Lake allows you to have ACID transactions on the data lake. So if you're using Apache Spark for big data workloads within Azure Synapse, we have now the general availability of Data Lake within Azure Synapse. So this is a really important milestone that we achieved. And finally, we've announced also the general availability of the Azure Cognitive Services integrations within Azure Synapse. So if you're using cognitive services, and it could include scenarios like translation, for instance. So you need to translate some text. So let's say you're getting customer feedback on a different language. You can use our cognitive services to automatically translate that for you. Or even forms recognizer. So if you have some documents that you need to run the form recognizer API that we have in cognitive services, this is well integrated into Azure Synapse today. Okay, so let's talk about some customers. I'm going to mention 4 cases real quickly here. This is not an extensive list of all of the customers we're working with, but gives you a sense of how the industry is using Azure Synapse this day. The first one is NeoGrid. NeoGrid service thousands. They are an information services provider that work globally. They have thousands of customers from Brazil to Germany to Japan, and in fact, in more than 150 customers they operate. Now, the challenge with them is how they, the solutions that they offer for supply chains in manufacturing, and the way they look into it is they connect to the point of sale to see how products are being sold, so that they feed that information back to the supply chain. So instead of learning from how the retailer is relying on assumptions based on previous orders, they look directly at the point of sale. And this is important because it gives you a real-time insight into sales and really helps feed the supply chain to help the stores understand how they should be working their supplies. Now, they had an aging and costly data warehouse that didn't scale well, and they migrated to Azure Synapse, and that's, because of that, they realized massive gains in performance, and it's really easy for them to scale up and down. In retail and manufacturing, it's really, they have lots of challenges with seasonality, so having this scalability aspect of the cloud is really important for them. So another example that I'll say today is UBS. UBS, of course, UBS Wealth Management in North America, the very traditional company. They have 150-year history in the industry. And in their case, they had an enterprise data warehouse which was reaching the end of life, but also they had new requirements for data science and other workloads that their current solution did not satisfy. They're also looking for an end-to-end solution for data governance and cataloging, which is something that we integrate well with Azure Synapse. The solution that they adopted Azure Synapse modernized their data platform, and as a result, they gained on scalability, faster data ingestion from any source, virtually any data source, and much better cost performance than what they had before. The third example that I'll say today is Becton Dickinson. Now, BD, they're a leading medical technology company. They're known for an application called BD Pixies, which essentially tracks a medication from when it's dropped off at the hospital pharmacy until it gets administered to the patient. So this is a really tight workflow that needs to be really well controlled. So they have this application called BD Pixies that does that. And they partnered with Microsoft to develop their new Health Insight Diversion Management Analytics application. And this application gathers data from multiple sources, analyzes more than 50 unique signals, looking for outliers, and then it creates a risk score for each user. To improve accuracy, those users are compared against a dynamically determined cohort, so that they can compare against other users, and they keep that on a feedback loop to keep training the model and making it better. And over time, the machine learning model gets better at identifying suspicious behavior. So it's really about identifying suspicious behavior with the goal of intervening early enough to get potential diverters. They need to help, before the patient safety is compromised. So they're doing really interesting work with machine learning. And finally, the last example that I want to mention today is Walgreens. Walgreens, they're the U.S. subsidiary of Walgreens Boots Alliance. They have over 10,000 domestic pharmacies and retail outlets. And the challenge with them is their ability to serve their star team members and customers really depends on their data center ability to rapidly respond and generate insights from years of historical information. The challenge that they had was as the company grew, so had their data center. Their data center had to grow with the company as well. But the on-premises data warehouse that they had was expensive and really slow and hard to scale. So if you have an on-premises data warehouse, you need to procure hardware. It's an expensive and costly operation to do. So by moving to Azure Synapse Analytics, they dramatically enhance their operations. They lower their TCO and they modernize the business processes and decision-making process as well. So now they get to scale the data warehouse up and down as needed, and really makes their time to insight much quicker because it's much faster to start and finish any new product. So that's everything I had to share today. We could spend the whole day talking about Azure Synapse. For now, I'll turn it back to Joseph so that he'll dive into the architecture and demo.
Thank you so much, Peri. So TJ did a great job of setting up the problem statement and kind of why we're here, right? The center, we're focusing around the concept of modernization. I went through some of the Confluent components that can make, they can unlock some of these possibilities. And then Peri, of course, went through the power of Synapse and some really relevant use cases. So let me now kind of tie that all together, and we'll build this demo for you, and we'll go through it. So let's take a look at a pretend retailer. We'll call them Blue Mariposa. Let's look at how they go about their data warehouse modernization journey by migrating data from Oracle and Postgres to Synapse. Let's say Blue Mariposa uses Oracle on-prem to store most of their business critical stuff like customer data. However, they have online orders in a cloud instance of Postgres. Maybe another line of business owns the data store in Postgres, or they haven't completely integrated an acquisition, something, right? But the point is they've got some data silos across on-prem and cloud environments, which is a common situation for many organizations. That is preventing them from getting a more complete and holistic view of their customers so they can create real-time personalized promotions, which is a thing that they want to do. The data science team at Blue Mariposa is eager to start analyzing this data and generating insights, but they face a couple of challenges. First, the data they need lives in two separate systems and environments, like I said, Oracle and Postgres. And they'll need to access and merge that data in order to get a unified view of customer purchasing behaviors and preferences. Now, second, real-time analytics is a problem data warehouses have solved, but their current data warehouse doesn't have the usability or performance necessary for the type of real-time and relatively sophisticated analytics they're trying to conduct. So the data science team advocates migrating to Synapse, which kicks off their journey of moving to a cloud data warehouse. Using Confluent and our library of pre-built source and sync connectors, we can build and scale real-time multi-region hybrid data pipelines that move data from any source environment to the cloud data warehouse of your choice. Let's go through an overview of our implementation steps. Number one, sorry about that, I'm going to go for a while. Number one, we'll set up a self-managed Confluent platform cluster on an on-prem Kubernetes environment. Two, we'll extract customer data from Oracle to Confluent Platform using the Oracle CDC Source Premium connector. In this demo, we're choosing to start with an on-prem environment running in Kubernetes to match the environment of our Oracle database, which we already said was on-premise. But you can also choose to connect your Oracle database directly to Confluent Cloud through that same CDC connector if you'd like. Third, we'll stream the customer data from our self-managed Confluent Platform cluster in Kubernetes to our fully managed Confluent Cloud cluster with cluster linking. That's another good reason why we did CDC to an on-prem Confluent installation, so we could show cluster linking, which is incredibly cool and very useful in this common scenario that we're illustrating. Fourth, we'll extract order data from our second data source that's already in the cloud. That's the Postgres cloud instance with the fully managed Postgres source connector, putting that data in the Confluent Cloud. 5, once all of our data is in Confluent Cloud, we'll merge and transform the data sources with KSQLDB, generating a unified 360-degree view of the customer like we've always wanted. Note that for basic transformations like filtering or masking or things like that, some of that can be done in Kafka Connect using a feature called single message transforms, or sometimes called SMTs. at the level of the source connector. Now that's some flexibility, convenience, and potential cost savings. It's a fine thing to do. But for our purposes today, we're going to keep it all in KSQLDB because it's a more powerful and more generalizable tool. And I think it makes for a cooler demo. Honestly, it's a lot more flexible and you'll use it way more. Finally, we'll load the clean and merge data into Synapse using our fully managed Synapse Sync connector, where the data science team can go and do their thing, like creating real-time promotional recommendations. And with that, let's look at this step by step. Let's take one more. Okay. All right, let me get this just right. Okay, go full screen. That wasn't right. Sorry about that. All right. For the demo, we'll be deploying Confluent for Kubernetes, which automates deployment of Confluent platform and makes it easy to configure all the components of our self-managed offering with a declarative API-driven experience that gives you a cloud-like elasticity, but in your on-prem environment. To set up Confluent for Kubernetes, make sure you have kube control and Helm free installed. Create a namespace to host your pods, and then set it as your default namespace. Then install Confluent Operator using Helm. All right, here you can see we've enabled cluster linking as part of our deployment. Next, we'll install platform components using kubectl. It'll take a moment for all of our pods to deploy, but by using Movie Magic, we could speed that up. Awesome. Once all the platform components are installed, let's head over to Confluent Hub to search for our Oracle CDC Source Premium connector. This is a self-managed connector, so we need to download it and bake it into the Docker image so we can find it later in Control Center, so it'll be class loadable by Kafka Connect when it runs. So we'll run the Confluent Hub install for Oracle CDC connector. Next, let's take a look at the customer data we have in the Oracle database. In the customers table, we have fields like customer ID, customer name, and some other customer information. We're going to be using the customer ID field later to match our customer data to that customer's orders. In the Confluent Cloud Control Center, we could see the Confluent platform cluster that we just deployed through Kubernetes and the Oracle CDC Source Premium connector. We'll supply all the necessary settings to access our Oracle database. This connector allows you to pretty reliably and cost-effectively implement continuous real-time syncs by offloading that data, getting that data out of the Oracle database and in the Kafka topics. Once you've created the connector, check to make sure your connector is running. It's always a good idea. Now, let's check this new topic, oracle.admin.customers, created by the connector to see the records coming from Oracle. With our pre-built connector, you've now performed a highly complex integration that would otherwise would have taken more than a few engineering months to replicate in-house. Trust me, this is trickier than it sounds. It's great to have connectors. Next, we'll bridge our two environments from our self-managed cluster with Oracle data to a fully managed cluster on Confluent Cloud using cluster linking. Let's start by provisioning our Confluent Cloud cluster. We'll select a cluster type and begin configuration. We'll select a cloud provider, a region, an availability zone, and launch the cluster. To enable cluster linking and mirror the on-prem Confluent platform cluster to our new Confluent Cloud cluster, we've just created, make sure that your destination cloud cluster has cluster linking enabled. Using the cloud CLI, we'll create a destination-based cluster link. Then we'll create a mirror topic on the destination cluster and associate it with the cluster link. Let's go. Oops, sorry, I'm a little ahead of myself. All right, let's go into the Confluent Cloud UI, and you can now see that the Oracle admin customer topic exists in our Confluent Cloud cluster as a result of that cluster link. Pretty cool stuff. Now let's switch gears and examine our second data source, which is the orders data in Postgres in that cloud instance of Postgres I mentioned. Let's take a look at the orders table. It has fields like customer ID, product name, order, date, and cost. We'll need to get this data in Confluent Cloud as well, but we'll do this using fully managed Postgres source connector. Unlike that self-managed Oracle connector we used earlier in Kubernetes, the fully managed Postgres connector in Confluent kind of abstracts away all that operational burden. So we can get started quickly with just a little bit of data, and it's literally just a few clicks. We'll tell the connector about our Postgres database, launch it, and validate it has a new topic. That's a happy thing. Now that our connector is up and running, let's quickly take a look at the topic it created, which is Postgres_orders, and check out the events that are there. Looks like they're there. Once all of our data is in Confluent Cloud, it's time to merge and transform it using KSQLDB, which lets us do real-time processing, real-time stream processing with SQL. Let's create a new KSQLDB application. That's the place where our queries live, and write some queries. First, we'll create a stream of customer data from the customer topic. And now we'll create a stream from the orders topic. Then we'll merge the two streams on the common customer ID field. Next, we'll wait for that. I got ahead of myself. Great. Next, we'll begin cleaning the data. We want to clean the data here in Confluent because the clean data can be used by multiple downstream applications and systems without needing to reclean it and reprocess it all over again. So let's start by scrubbing the customer data from Oracle. We'll need to create a table from that system, from that stream. That's what customer data is. Customers are things, so they're going to go in a table. But we may not want to provide certain sensitive data on a customer to the data science team. So let's remove fields like preferred credit card number, and hopefully that was encrypted anyway, but we won't even include it. Now we want to create a table that aggregates certain metrics from order data in Postgres. The data science team often wants to see variables like total number of orders or total lifetime spend for each customer. So why not just aggregate that in real time? We'll aggregate the count of order ID and the sum of order amount by customer ID to create those two new fields. We also want to know when the customer's most recent order was. So let's create another new field called last order with the most recent order date. With the data cleaned, let's join the customer and order data from the two data sources using the common field customer ID so we can get a unified view of our customers. We don't need to load customers who haven't made a purchase in the past 5 years or longer from into our new cloud data warehouse. I think that seems fair. So we'll filter out those customers based on their last order field and save on storage costs to the new data warehouse. Now that we have our cleaned, unified view of the customer, let's load this into Synapse using Confluent's fully managed Synapse connector, similar to the Postgres connector we used earlier. It's a quick and simple process to launch a fully managed connector. Let's tell the connector about our Synapse data warehouse, the URL, username, key, database name, table format, and launch the connector. With that connector fully provisioned, let's go over to Synapse and see what's happened. We could see that, in just a moment. Awesome. We could see that all of the data is here. We won't go through the details, but it's sufficient to say that we've taken our data from our legacy database, bridged it from an on-prem deployment to a cloud environment, joined it with other valuable data, and processed it with KSQLDB, floated it down to Synapse where the data science team would be able to accomplish and conduct their growing analytics operations. All right, we're going to keep this slide up, but I'm going to hand over to TJ to kind of close out our session.
Awesome. Thank you so much, Joseph. That was a really great demo. It really brought it to life on how to connect those on-prem environments and cloud data sources to Synapse with a few lines of code there with those fully managed connectors. So we have a few minutes left. Thank you all for joining us. I would love to open it up to questions with Peri and Joseph. So feel free to use the comment section in your console and anything you want to follow up on, please let us know. In the meantime, while the comments and questions are coming in, just wanted to serve up some questions to Joseph and Peri. So Joseph, I want to start with you. Obviously, you are really familiar with Apache Kafka versus Confluent. Can you just describe from a developer's perspective, what are the really cool extended capabilities that Confluent Cloud offers that Kafka doesn't, that makes your life so much easier when you set up these different Kafka connections?
That's a great question. I mean, it really comes down for me. My background is in operations, right? So I ran Kafka clusters that developers work with. So the operational pieces are the ones that usually jump out to me the most. So Confluent platform, which you can deploy anywhere, gives you what we call C3 or Confluent Control Center. So that gives you a nice UI for your cluster. That's something you don't get out of box. With Confluent Cloud, that's kind of built right into the platform. So with either of our products, you get that nice GUI. Security, out-of-box security, including RBAC and ACLs, a lot of things that you can do with Apache Kafka that are much more simple with Confluent layered on. Cluster linking for replication is best in breed as far as I'm concerned when digging into that technology. And then for my developers, we talked about KSQL DB a lot, right? And we didn't get to talk about what that's actually built on. And it's built on something called Kafka Streams. And the thing is, with Kafka Streams, you write those in either Java or Scala, which I think most people would agree is a lot less accessible than, say, SQL statements and CRUD statements. So that, it's great to have a feature or an ability to do something, but when you can open up the accessibility and broaden it from, 5% of my engineering team to 50% of my engineering team, you're going to have a much more useful system. So all the things that all the things that come with Confluent platform that make it easier to keep it running, deploy it, and to develop on it are the things I really like. And one other one, for operational standpoint, when you run Kafka at scale, one of the things that people generally run into is rebalancing of partitions, right? So data is spread across partitions, which are spread across brokers for high availability and throughput. But sometimes data gets hot on one partition, and whether you're going in Confluent Cloud, it's happening under the hood, or Confluent Cloud, but Confluent platform, we have something called auto data balancer, which automatically takes away. And there are literally teams of operations out there that just rebalance Kafka all day. We have a mechanism that does that automatically. So if you have platform, it's built in. If you have Confluent Cloud, it's built in. Saves a ton of time. I hope that answers your question.
Awesome. No, that does. I know OSS Kafka usage is definitely a method for developers to get started easily. So understanding the differences of what you get with Confluent Cloud versus OSS Kafka is really, really important. So Peri, a question for you. You mentioned log analytics, obviously IoT use cases, clickstream data, application monitoring. Can you just drill into kind of what is packaged up now with Azure Synapse as it relates to log analytics with your recent announcement?
You're on mute, Peri.
Yeah.
Of course. This is the conference call bingo card. I'm checking I'm on mute one for today. So this is a good question. So we've had Azure Data Explorer. We've had Data Explorer available in Azure for a while now, and these are customers used to go for raw data that comes from telemetry and stream analytics and IoT systems. It's just that the engine is better optimized to handle data where you have free text or unstructured data coming from a diverse set of sensors or telemetry systems. And now we've brought the Data Explorer integrations with Azure Synapse SQL. So we have the language support, we have the engine support. The searches are optimized for those scenarios. So for our SQL engine, we have the indexes, and the engine will optimize for a SQL environment, of course. For Data Explorer, it aligns better for data coming from telemetry sources and IoT sources. And our customers have been using Data Explorer for a while now. So it made sense for us to bring that integration into Azure Synapse. And that's what we announced last week. We're super excited about this workload as well.
Awesome. Yeah, we're super excited about that as well, since log data, machine generated data, whether it's coming from an IoT device or whether it's coming from your SaaS application that you're trying to monitor, is a massive real-time data stream. And being able to bring that from real-time event processing all the way to analytics and value, and having that complete end-to-end capability is something that we're really thrilled about. So Joseph, if you want to click to the next slide, we're at the top of the hour. Just want to say thank you to all of you. And also a quick reminder to grab your swag, t-shirts and hoodies, beanies and hoodies available. So thank you, Joseph. Thank you, Peri. Really appreciate the presentation. Super informative, and look forward to talking with you all soon. Bye, all.
Bye, everyone. Thanks, TJ.
Bye-bye, everyone. Thanks, CJ. Thanks, Joseph. Take care.